All right, CNT125. We're looking at Chapter 7 on virtualization and cloud computing. So let's jump right in. This first podcast, we're going to focus mainly on virtualization. Virtualization, the nice part is from 120 and actually early here in 125, you have already set up a virtual machine that we use in our lab. So you have a little bit of virtualization under your belt already. Virtualization is just simply the emulation of a computer system. Could be operating system, a particular application on another physical system. So think about our lab machines. We have a certain version of Windows operating system running on that physical computer. We have VMware running on top, and in there we have put a virtualized Linux computer in there. That is virtualization. They can be virtual workstations, virtual servers, and actually can be configured to use different types of drives and CPUs and that sort of thing. That's what your virtualized system or VM is, virtual machine is. To users, your VM appears no different than a physical computer. It's running the same software. This actually allows a couple things as they talk about in the chapter. One of them being you could actually gen up a virtual machine, work with it, test things, whether it be test new applications you're going to install, new settings you're going to install, new certain server applications you're going to run. You could test all that, get all the bugs worked out before you make it go live somewhere else in your network or in your system. Very useful to do. The actual host is the physical computer. This would be our Windows machine that we had in the lab room. The guest is each of the virtual machines that are on top of there. And if you think back, there was already one or two virtual machines on there. You added yours on top of that. So this actual physical box could hold a number of different virtual machines. The hypervisor is actually the software that we ran that we built the virtual machine in. So in our case, it was VMware. VMware Player is what we use to build our virtual machine in. That is actually the software that is allowing that to happen. The book talks about, hey, here's your physical computer. Inside, we're building the hypervisor's running, and we're building virtual machines in that hypervisor. And then eventually, we'll talk about the hypervisor connecting to the physical NIC and to the network and so forth. There is actually two different types of hypervisors, type 1, type 2. The type we used in our lab room is actually type 2. Let's talk type 1 and then we'll work in toward or remind ourselves of type 2. Type 1 hypervisor, this actually installs in the computer before any operating system is installed. So you can almost consider this hypervisor is the operating system for the physical box. This type of hypervisor, and they give you examples in the book, Zen Server by Citrix, ESXi by VMware, Hyper-V by Microsoft. This actually becomes the operating system for that box, and it's designed to use minimal processing, and you can put your virtual machines on top of there. So if you're going to set up a true server that's going to host multiple virtual machines, you would use more than likely a type 1 hypervisor because it uses minimal processing from the physical box to run these virtual machines. It's just there to host the virtual machines. That's pretty much all it's there for. Those would be these examples they talked about in the book: Zen Server, ESXi, Hyper-V, that sort of thing. The type 2 hypervisor, this is what we actually set up and ran. This, you have the host operating system, in our case it was Windows, then we put the hypervisor on top, VMware, then we put the virtual machine inside the hypervisor. And you can actually reverse this. Once upon a time, my laptop was running Ubuntu. I put VirtualBox on top of Ubuntu, and then I put Windows, I think it was XP in those days, Windows XP in the VirtualBox. So I had it totally flipped upside down. I had Linux as my host OS, VirtualBox as my hypervisor, and then XP running inside. So the Type 2 hypervisor is the kind we're using in lab. Things like Hyper-V, VirtualBox, VMware Player, Linux KVM would all be examples of. Now these are not going to be near as powerful as Type 1 because the host operating system is using some of the processing, and then the hypervisor and virtual machines are using processing. So there's a lot of sharing going on with the Type 2 hypervisor. But it's actually very handy to do lots of building up of systems and testing things with the Type 2 before you make things go live. And here in the book they show you examples of, and I kind of give you an idea with your Type excuse me, Type 1 hypervisor, you actually have the hardware itself, the Type 1 hypervisor, and then your virtual machine sitting on top. With a Type 2, you actually have the host operating system like Windows 10, Windows 8, whatever. Then your Type 2 hypervisor like VMware, and then your virtual machines running inside of that. And I remind you, these are some of the big players. These are some of your big players with virtualization. Microsoft Hyper-V, Zen, KVM, VirtualBox, VMware, VMware, ESXi kind of thing. With our virtualization, this should look familiar. This is the screen that we encounter when we were setting up our virtual machine. They remind us that the software and hardware characteristics are assigned when it's created in the hypervisor. Yeah, when we created our virtual machine, we actually went in here and adjusted the amount of memory we were allocating to the virtual machine. We even came in here and adjusted the settings for the network adapter. So we can actually specialize the settings that each virtual machine would get, and actually many times you can adjust this. Some of these settings you can adjust while the virtual machine is live. Some of them you shut it down, shut the virtual machine down, adjust the settings, boot it back up, and all of a sudden it has more hard drive, more processing, etc. So it's very customizable in many cases. There is different network connection types with your virtual machines. And actually we touched on this a little bit when we created our virtual machine in the lab. Every virtual machine has its own virtual network adapter, or VNIC, and that is used to connect that virtual machine to the network or other virtual machines. The VNIC operates a data link layer just like a regular NIC does to get network access. And the virtual machine could actually have several virtual NICs. So if I think of my host machine, I might have multiple virtual machines in there, so it's going to have multiple VNICs. The only limitation is usually the hypervisor limits how many VNICs you can have, how many virtual machines in there, and how many VNICs you can have. That would be limitation of the hypervisor. And then each VNIC is automatically assigned a MAC address. And if you remember when we looked at our MAC addresses, they all started with the same prefix because they were all assigned from, in our case, VMware, all assigned from VMware. Here is actually looking at our network adapter settings with our virtual machine, seeing there is actually settings that you have on the virtual NIC. When the first VM's VNIC is selected, the hypervisor creates a connection between that and the host, and this might actually be called a bridge or a switch. In the hypervisor, there is actually a virtual switch, and that virtual switch is there to allow connection between multiple virtual machines and the physical NIC on the machine. That's what it's there for. So it is almost like a switch built into the system now that would allow these virtual machines to connect to the switch and actually connect to the physical NIC on the box. It's a logically defined device, operates the data link layer, passes frames back and forth, allows virtual machines to communicate with each other and or the LAN, and then the hypervisor is going to control this virtual switch. That's kind of what's there, and I think they even have a picture in a book of that for you. Yes, here's our different virtual machines. They're VNICs attaching to this virtual switch inside the hypervisor, and that virtual switch is actually attached to the physical NIC on the box. This is all being done in the hypervisor, all the functions of the hypervisor. And they're even showing you here, if I have two physical NICs, I can run that through a router and actually have this here, host A and host B, communicating with each other just like I would in a regular network. Pretty slick. Now, with our network connections, our VNICs, there's three main types we run into: bridge, NAT, and host only. And again, hopefully you remember this from when we were setting up our virtual machines. And you need to select them. As you say, as you're building a virtual machine, that's something you select, and you need to select them carefully for the function that you want this virtual machine to have. With bridged mode, this is the one we end up using in our lab machine. With bridged mode, the VNIC accesses the physical network using the host machine's NIC. So my virtual machine is literally being bridged to the physical NIC in the system. So It's going to contain its own IP, default gateway, network mask, all that good stuff from the LAN itself. So the virtual machine is going to appear like it's a regular node on the network, just like the host machine. And other machines, other nodes on the network can communicate directly with it, not even realizing it's an actual virtual machine. So the picture they show you in the book here, I have a couple of virtual machines in my hypervisor connected to the physical NIC and out to the network. So if I look at the actual network itself, here's the physical NIC on the host machine. It's getting a 192.168. What you'll notice is these virtual machines in here are also getting a 192.168. And if you look a little closer, .131, .132, .133. All these virtual machines in the actual host system are all getting IP addresses from the DHCP server on this network. So they're all getting their own IP. Each virtual machine looks like its own node on the network. This is the common VNIC setting if you want this virtual machine to be connected to the network and reachable through the network by its own IP address. And here's a reminder, when we set up our virtual machine, we selected bridge mode to do that. With NAT mode, with a NAT mode for my VNIC, what's going to happen is the actual host machine is going to NAT whatever IP it gets and turn around and give me an IP address from its own DHCP server. So if I take a look, here I have the network. Here's the actual NIC on the machine attached to the network. It's getting a 192.168.1.131. With NAT mode on my VNIC, what happens is, inside here in the hypervisor itself has its own DHCP service, and it hands these virtual machines a NATed address, in this case a 10.1.1.129, 10.1.1.128. So it has NATed the 192 and turned around and created its own DHCP service and hands those NATed IP addresses out to the virtual machines. So these virtual machines are being hidden behind the hypervisor on this physical box. So these machines are reachable, but they're reachable through this host system. So they're kind of being hidden behind there. This does not work so well if you want these virtual machines easily reachable from the network. So this would have maybe some settings you would need to do, port forwarding kind of things, to be able to reach these boxes, or you're setting them up for security purposes behind there. And here in VirtualBox, you're seeing setting of NAT for my VNIC. With host only mode, the last mode, this is really for kind of like testing purposes. When I'm building a machine up and I'm really running it through its paces and testing, and I don't want it going out anywhere. I don't want it reachable. I don't want to go out. I just want to build this thing up and test it. I can use host only mode. In this case, the VNIC is, I have IP addresses here, but it's not going to even pass the traffic outside, out to the physical network. So these are really pretty much only internal IP addresses. So I could build these two nodes up. I could set one up as like, a host Windows machine, and this one over here is a Windows server, and start working on testing functionality, access, that kind of thing, and really run it through its paces, but keep it hidden off the network. That would allow that, kind of like the building and testing mode, if you will. So those three modes, as we said, bridge, NAT, and host only, those are settings on your VNIC. Make sure you understand the difference between them. They do have their applications. In our labs, most times we're going to go with bridged mode for what we're trying to do in our lab room. All right, we do have some pros and cons of virtualization. Advantages are it's efficient use of resources. I don't need 4 or 5 physical boxes. I can have one. Because of that, I might have some cost and energy savings powering just one box. And I do have some threat and fault isolation because it's only in that one physical box, if you will. I can shut down that virtual machine. It's simple for backups, recovery, and replication. I can literally replicate that virtual machine and move it to another physical box if I need to. Downside is I do have compromised performance. putting multiple virtual machines on one physical box, I need a lot of memory, or it's going to bog it down. It is more complex system because I have more things I have to check and worry about on one physical box. I do have licensing issues. It's not like I'm going to get away with having free virtual machines on there. I have to pay for licenses on each one of those virtual machines. And I do have a single point of failure. If that physical box has a failure, I might lose 3 or 4 servers that are sitting on there, virtualized systems sitting on there. So there is a drawback to that. All right, we'll come back in the next one, talk a little bit more about virtualization.